Hello viewers, welcome to my YouTube channel Mathematics Medicine. So in today's video we are solving this beautiful integral. So I have integral from -1 to +1 of square root of 1 minus x squared over 1 plus x squared dx. So actually I saw this problem on Facebook, so I decided to solve this problem for my subscribers, alright, for you only. Okay, so if you are new to this channel, please don't forget to subscribe, like, comment, and also share, and click the notification button so that anytime we upload an interesting concept like this, so you'll be the first to watch. Okay guys, let's dive into the work. Sit tight, bring out your pen, your book, because you're gonna learn a lot in today's video. Okay, now let's get started. So the first thing I'm gonna do if I want to solve this problem is to check if this function that we wanna integrate is an even function or an odd function. So how can you check if a function is an even function or odd function? So the first thing I'm gonna do is to let f of x be equal to the function we want to integrate, okay, which is square root of 1 minus x squared then over 1 plus x squared. The next thing I'm gonna do is to substitute x to be negative x. So we have f of negative x will be equal to, so square root of 1 minus negative x raised to the power of 2 then over 1 plus negative x raised to the power of 2. Okay, so negative x raised to the power of 2 will give us x squared. So we have square root of 1 minus x squared then over 1 plus x squared. So which is also equal to f of x. Okay, so since f of negative x is equal to f of x, okay, then we can say f of x is an even function. Is an even function. Okay, so let's just say if f of x, f of negative x is equal to, let's say if f of negative x is equal to negative f of x, then you say it is what? F of x is an odd function. Okay, but the function we are integrating here is an even function. Okay, so we work according to the even function. Okay, now let me remind us a beautiful theorem in calculus. So for an even function, if you have integral from negative a to positive a of f of x dx, so this will give you integral from 0 to a of f of x dx. Sorry, we have to put 2 here. So 2 multiplied by integral from 0 to a of f of x dx, if and only if f of x is an even function. Alright, now since we have this, we can now solve this problem successfully without any fucking problem. Okay guys, so let's move on. So I can just let I be equal to the integral. So that will be I is equal to integral from 0 to 1. Okay, so our f of x, which is square root of 1 minus x raised to the power of 2, then over 1 plus x raised to the power of 2 dx. So the next thing I'm going to do is to write out the series representation of 1 over 1 plus x squared. So I can say this is equal to 2, then multiply by integral from 0 to 1. So instead of me writing 1 over 1 plus x squared, I can just write sum of n from 0 to infinity of minus 1 raised to the power of n, all right, of x raised to the power of 2n, then multiply by integral, square root of 1 minus x squared dx. Okay, so we can bring out the sum. So we have I is equal to 2 multiplied by sum of n from 0 to infinity of negative 1 raised to the power of n, integral from 0 to 1 of x raised to the power of 2n, so 1 minus x squared, then raised to the power of half, square roots. So that will be raised to the power of half, then dx. So the next thing we're gonna do is to make a beautiful substitution right here. So by making a beautiful substitution, so we can say let x raised to the power of 2 be equal to any variable you like. So I'm using lambda. Okay, I'm using lambda. So we can now say x is equal to lambda raised to the power of half. Then you differentiate. So we have the x is equal to 1 over 2. We differentiate this with respect to lambda. So you have 1 over 2 multiplied by lambda raised to the power of negative half the lambda. Okay, so that is what we're gonna have. So then we have I is equal to 2 multiplied by sum of n from 0 to infinity of negative 1 raised to the power of n, integral from 0 to 1. Yeah, the limit is not changing, okay? Because if you input 0 here, you still have 0. If you input 1 here, you still have 1. Okay, so instead of you writing x raised to the power of 2n, you can just write lambda raised to the power of n, then 1 minus lambda, then everything raised to the power of half. Then dx is now 1 over 2 lambda raised to the power of negative half d lambda. Okay, so we can see 2, we cancel out 2 right here. So what we have now is I equals sum of n from 0 to infinity of negative 1 raised to the power of n integral from 0 to 1. So lambda raised to the power of n and then lambda raised to the power of negative half. So that will give us lambda raised to the power of n minus half. Then multiply by 1 minus lambda, then raised to the power of half, then the lambda. That's beautiful. Now, if you check this particular integral that we have now, it looks like the gamma form, the beta function. Okay, so let me quickly remind us the beta function. So we know that beta of n comma m, so this is going to give us integral from 0 to 1 of x raised to the power of n minus 1, then 1 minus x, then raised to the power of m minus 1 dx. So how can we transform this in this form? Now, this is what you're going to do. You're going to add 1 and subtract 1. Okay, you add 1 and you subtract 1. You add 1 and you subtract 1. Okay, so then we're going to have I is equal to sum of n from 0 to infinity of negative 1 raised to the power of n, then integral from 0 to 1 of x raised to the power of, so negative half plus 1 will give us half. So this is lambda rather. So we have lambda raised to the power of n plus half, then 1 minus lambda, then raised to the power of half plus 1 will give us 3 over 2, then minus 1. So that shows that the value of n right here is, don't forget negative 1 right here, is n plus half, and the value of m right here is 3 over 2. Okay, so we're going to say this is equal to sum of n from 0 to infinity of negative 1 raised to the power of n. Then we have beta of let me just write it here. So we have sum of n from 0 to infinity of minus 1 raised to the power of n. So we have beta function of n plus half, then comma 3 over 2. Now let's move to the next page. So let me quickly remind us a beautiful property of the beta function. So beta of n comma m, so this will give us gamma of n multiplied by gamma of m, so over gamma of n plus m. So what you have now is I is equal to sum of n from 0 to infinity of minus 1 raised to the power of n, so then gamma of n plus half, then gamma of 3 over 2, then over gamma of n plus half plus 3 over 2. Okay, so this will be equal to, gamma of 3 over 2 will give us square root of pi. So we have square root of pi over 2 rather. So we have square root of pi over 2, then multiply by sum of n from 0 to infinity of minus 1 raised to the power of n, then gamma of n plus half, then everything over gamma of n plus 2, because 1 over 2 plus 3 over 2 will give us n plus 2. Cool. Now, next thing we're gonna do is to write out the representation of the gamma of n plus half. Okay, so we have gamma of n plus half. So this is gonna give us root pi multiplied by 2n factorial over 4 raised to the power of n multiplied by n factorial. So that is gamma of n plus half. Okay, so we can now say, so let me just use my my green marker. So we can now say I is equal to root pi over 2 multiplied by sum of n from 0 to infinity of minus 1 raised to the power of n. So instead of writing gamma of n plus half, so we can just write gamma of root pi 2n factorial, then over 4 raised to the power of n factorial, then multiply by gamma of n plus 2. So square root of pi multiplied by square root of pi will give us pi. So we have pi over 2 sum of n from 0 to infinity of minus 1 raised to the power of n 2n factorial over 4 raised to the power of n factorial, gamma of n plus 2. Okay guys, so the next thing we're going to do now is to expand this series so that it will be very easy for us to solve. So we have I is equal to pi over 2 then into brackets. So now if you substitute n to be 0, minus 1 raised to the power of 0, that will give us 1. Okay, 2 times 0 will give us 0, so 0 factorial will give us 1. 4 raised to the power of 0 will give us 1. 0 factorial will give us 1. 0 plus 2 will give us 2. So gamma of 2. Remember that gamma of n is equal to n minus 1 factorial, okay? So you can now say gamma of 2 is equal to 2 minus 1 factorial, which is also 1. Okay, so everything here, when you substitute n to be 0, you have 1. Then when you substitute n to be 1, minus 1 raised to the power of 1 will give us negative 1. So you have minus. Then 2 times 1 will give us 2. So 2 factorial over, so 4 raised to the power of 1 will give us 4. Then 1 factorial, so multiply by 1 factorial. Then multiply by, so gamma of n plus 2, that is 1 plus 2, that will give us gamma of 3. And gamma of 3 will give us what? 3 minus 1 factorial, so which is 2 factorial. Okay, so when you substitute n to be 2, so minus 1 raised to the power of 2 will give us 1, so you have plus 1. Okay, so let me just remove that one because it's just 1. So when you substitute n to be 2, 2 times 2 will give us 4, so we have 4 factorial, then over 4 raised to the power of 2, 2 factorial, okay, then 2 plus 2, 4. So gamma of 4, that will be 3 factorial, okay, then minus, when you substitute n to be 3, so you're going to have 2 times 3 will give us 6, so you have 6 factorial over 4 raised to the power of 3, okay, then you have 3 factorial, then you have 3 plus 2 will give us 5, and so that will give us 4 factorial. Then plus, when you substitute n to be 4, so you have 2 times 4, you have 8, so we have 8 factorial, then over 4 raised to the power of 4, okay, then you have 4 factorial, then this should give us 5 factorial. So that is how it goes. Okay, all right, so that is what we have. So now let's simplify this completely. So let me just clean this top so that I can have some space to work. We are almost there. I'm sure you are getting something. Okay, so you can watch this again so that you can get what we are doing right here. All right, so let's move on, guys. So let's simplify this completely. So we have I is now equal to pi over 2, then into bracket 1 minus. So you can see 2 factorial, we cancel out 2 factorial, then 4 times 1 factorial will give us 4. So we have 1 over 4 raised to the power of 1. Then plus, so what again do we have? What do you think we can do here also? You know, 4 factorial, you can write this as 4 times 3 factorial. You know that. So this is 4 times 3 factorial. So 3 factorial, we cancel out 3 factorial. Okay. Then 2 factorial is 2. So 2 in 2 is 1. 2 in 4 will give us 2. So what you have now is 2 over 4 raised to the power of 2. So let's move on. Minus. So 6 factorial. So you can write this as 6 times 5 times 4 factorial. So 4 factorial we cancel out 4 factorial, and 3 factorial will give us 6. So this and this we cancel each other. So what you have now is 5 over 4 raised to the power of 3. Okay. Then plus 8 factorial. So you can write 8 factorial as 8 multiplied by 7 multiplied by 6 multiplied by 5 factorial. So 5 factorial we cancel out 5 factorial. So what you have now is 4 factorial right here. And then you can write 4 factorial as 4 times 3 factorial, and 3 factorial will give us 6. So this and this will cancel each other. Okay, and then 4 in 4, that's 1. 4 in 8, that is 2. So 2 times 7 will give us 14. So we have plus 14, then over 4 raised to the power of 4, then minus dot 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 dot. Okay, now I cannot clean this one. remember that we can represent this sum or this series in form of the Catalan series. Catalan number. You all know the Catalan number. Do you know it? Yeah. So that is where this comes from. So we have I is equal to pi over 2 sum of n from 0 to infinity. So Cn of minus 1 raised to the power of 4 raised to the power of n. Okay, so where Cn is the Catalan number. So everything here we've generated it into this form. Okay, so when n is 0, you have 1. Okay, when n is 1, so what is your Catalan number? Is still what? Is still 1. When n is 2, what's your Catalan number? So that will give us 2 right here. When n is 3, what's your Catalan number? That's 5. So that's how it goes. You understand me? Now, and then we have a formula for the Catalan number, that is the generating function for the Catalan number. So here's the generating function for the Catalan number. Let's say you have C of lambda, so which is equal to sum of n from 0 to infinity of Cn then of lambda raised to the power of n. So this would be equal to 1 minus square root of 1 minus 4 lambda then over 2 lambda. So what is the value of lambda right here, everybody? So that is negative 1 over 4. So then we can now say this is equal to 1 minus square root of 1 minus 4 into bracket negative 1 over 4 then over 2 into bracket negative 1 over 4. And this will surely give us 2 square root of 2 minus 2. Okay, so that shows that this sum right here is 2 root 2 minus 2. Then we have I is equal to pi over 2, then into bracket 2 root 2 minus 2. So if you factor out 2, you're going to have pi into bracket root 2 minus 1. And that is the answer to that beautiful integral. So if you like this kind of video, please don't forget to subscribe, like, comment, and also share. Thanks guys for watching. See you next time. Bye.